All right, ladies and gentlemen. Okay, yesterday we rotated regions about horizontal axes. Okay, today we're going to take regions and rotate them around vertical axes. All right, so here are my pictures. If I'm going to create discs around vertical axes of rotation, then my rectangles are going to have to be horizontal, which means my thickness is now dy. Okay, so now we're going to take our discs and we're going to go this way instead of this way. Okay. Okay. So just like yesterday, okay, pi r squared h is how we find the volume of a washer, okay, or a disc. So here we have pi r squared h minus pi r squared h to find any washer, okay, if we have a hole. Alright, which means if we add up all of these very small little washers, okay, this is how we find our volume. Now you notice how I have f of y and g of y. What does that mean? Okay, our functions are going to be in terms of y. So x equals y squared plus 4. X equals y plus 32. Whatever we have. Okay, but our functions are going to have to be in terms of y because our thickness is dy, which means we're integrating with respect to y. Okay? Process is still the same. We're still taking pi r squared h, and if we have any holes, pi r squared h minus pi r squared h. Okay, this time everything has to be done with respect to y. Okay, this is why it is important to draw in your rectangles so you know what you have to integrate with respect to. Eventually, these problems are going to be intermixed, where you're rotating around a horizontal axis, and then you're going to rotate around a vertical axis. So you're going to need to be able to tell, when do I do it with respect to x, when do I do it with respect to y.
What it would be is
yep.
vertical, and
yep.
like as if do it like that, and then you do that sphere around.
Okay, but we're gonna break it up. We're just doing vertical axis today. Okay, so here's our first example. Okay, we want the volume of the region bounded by these three functions when we take it about the y-axis. Somebody's phone back there. Okay. I just want to make sure. Okay. So I'm going to switch over to my smart notebook here so I can draw better pictures. Okay, so what do we have? We have y equals 0 is this right here, y equals 0. We have x equals 2, which is this vertical line. Y equals 2x squared is a parabola.
Stretched.
So at 2, so we have that, right? So what is the region that we are concerned with? This guy right here, right? So I really don't care about this piece of my parabola. Okay? Now we are rotating about what? The y-axis. Okay? So we're taking these horizontal rectangles with thickness dy. That way when we rotate around y equals 0, we get, okay, we get these discs around. They're these washers. Okay, so it kind of is like a cylinder, but, you know, with some stuff scooped out.
So it's like a typical big tub of ice cream that you
Maybe.
scoop the ice cream.
Okay.
It's ice cream.
The ice cream is on there.
So, can everyone visualize these washers going around? Can you imagine that they what they look like as they go around? Okay, because that visualization is important because we're going to use another method next week, and so we need to be able to visualize the difference. So anytime you do these problems, I need you to visualize those little discs going around, or those washers going around. Okay? So now we are integrating with respect to y, which means our functions need to be in terms of y. So instead of this being y equals 2x squared, we need to solve for x. Okay, technically plus or minus the square root of y over 2. But which piece are we working with? We're working with the positive. So I r squared h. Okay? Now we have washers, which means we need big radius squared minus small radius squared. So our big radius, okay, now remember when we were doing area, we go from what? Okay, we go from right to left. So right minus left. Still same concept. We want more positives minus less positives. Okay? So our biggest radius goes from where to where? 2 to 0, right? This is our biggest radius right here. So we have 2 squared minus our small radius from right to left goes from our parabola to the y-axis, right? So we describe that as square root of y over 2 squared. Minus 0, we don't have to put the minus 0. Very good. Our limits of integration are going to be from 0 to 8 because we're going with respect to y, so we need to look at the height of our region. What? No, when you plug it into your calculator, you can use X and it'll still give you the same thing. Okay. This isn't a very hard one to integrate, though, isn't it? So we have 4 minus y over 2. Okay. So yeah, we can integrate this one pretty easily by hand. Go ahead and do it in your calculator. That'll be nice.
Okay.
16.5. It's 16.5. You got what? It's the square root of that, not the square root of that. Yeah. Make sure that divided by 2 is under the square root of the y. getting it okay?
Why is it giving it to me?
What you do is you put this card in, and then you can multiply by 5.
Like 40 minutes. I didn't get them like 40 minutes.
A different interval. Where?
Each 40 minutes. Well, it's not the square root. Once it's 5, it's
You don't need that. You just do 4 minus 5. Oh.
There you go. Problem solved.
Yay, man.
Next problem. We want the volume of the region bounded by y equals x squared and y equals the square root of x. And we're rotating it about the y-axis. Okay. What does this look like? Well, we have y equals x squared, right? Y equals the square root of x.
Yep.
Right? So, we're worried about this piece right here. Okay? And we are what is this point of intersection right here? We all can figure that out. 1, 1. And we are rotating this about what?
So,
Y equals x squared and y equals the square root of x. Okay, so we have these horizontal rectangles with thickness dy that we're rotating around, and we're creating these washers. Right? Everyone visualize those washers going around. Okay. Now, since our rectangles have thickness dy, we need to go ahead and change our functions in terms of y. And so instead of y equals x squared, what are we going to call this? X equals... I'm sorry, I was saying one thing and pointing at another. Okay, y equals the square root of x turns to what? X equals y squared. Y equals x squared turns to x equals the square root of y. Alright? So, our axis of rotation is the y-axis. So we need to go pi r squared h. We have washers, so we need r squared minus r squared. So our big radius from right to left goes from where to where? Square root of y to the y-axis, right? So we have the square root of y squared minus, what's our small radius? Y squared to the y-axis. So y squared squared. Okay? So, limits of integration. 0 to 1. Okay? So in your calculator, to make things simpler, I would put in y minus y to the 4th. pi over what? Now, what's different about this guy? Okay, same region, correct? But now we're rotating about x equals 10. So we're creating a pretty big loop. X equals 10. Okay? So write this down. We have the same region, but now we're going about x equals 10.
He does speak some sense.
Do you like to do x equals 2?
Yes.
Let's do x equals 2. Okay. So we still have this same, I don't know, kind of looks like a bean. Flower petal. Okay.
Rose petal.
That's not rose. Okay. So we're going to rotate about x equals 2. And so we're going to get something that looks like this. Okay, we're going to have horizontal rectangles with thickness dy. So we create these washers. Alright. Okay. And remind me what these functions are. What is this function right here?
That is x squared. Y equals x squared.
Okay, so x equals the square root of y. And this is x equals y squared. Okay, remember, we have to go from right to left. So pi r squared h. Alright, we have washers, and so we need big R squared minus little r squared. Okay, so our outer radius, okay, remember we have to go from right to left, so where do we need to start? We need to start at 2, and then we're going to go all the way to where?
Y squared.
We're going to go all the way to y squared, because that's our furthest away function. So we're going to have 2 minus y squared, the quantity squared, minus our smaller radius, that whole, we're going to go right to left, so from 2 until square root of y. Okay, this would be 1. I would never make you do without a calculator. What are our limits of integration? 0 to 1, just like that. Sam, did you have a question? Chrissy's just... So you have something for me? It won't let you change it to a fraction? Okay, so multiplied by pi, what is it?
3.2.
Why do you think it won't let you change it to a fraction?
It's irrational.
Okay, it's going to be irrational because of that.
Yes.
Oh, there is that minus. Whew. Did you multiply by pi? There you go. Yeah, if you're going to write it as a decimal, you might as well multiply by pi. Alright, now I want to give you some time to start this assignment. Okay, I realize we have like 8 minutes, but it's better than 1 minute. Yeah, you got 0 minutes yesterday, so. The squared ones, once again, I do want you to try by hand. Okay. Now, while you're working on these, if you want to check the setup of 8, 9, or 10 before you integrate, you can do that. Okay. So I would definitely try to get 7, 8, and 9 finished so you can check the setup. If you want to set them up and then at home do the integration, that's fine. Will you hit the light, please, Tanner? Thank you.